Hi everyone, today I'm going to be walking through an art tutorial, and I'll start with sharing my screen to RStudio. So here I already started this workbook where I set my working directory to a folder on my desktop that contains the dataset we're going to be using, which is NHANE17. So I'm going to go ahead and run this first line of code and make sure it goes through. So it went through successfully down here with no errors or warnings. Next, I'm going to bring in all of the packages that I want to use. Since they've already been installed, I only need to run the library function, and using lapply, I can bring in all of them at once. So I'm going to go ahead and run that and make sure it goes through as well. And there's no errors or warnings here. After this, we're going to create a data frame called NH using the NHANE17 data. And to know if that went through successfully, we can look over here in our environment. So there was a list of variables that we were given, and the first thing that we have to do is change the values for don't know and refused to NA. And using this sign, we can write comments in our code, and it's always important to do that. So when we go back, we understand what we were doing. So change don't know and refused to NA. And to do that, we're going to type the following code. So this is going to be the data set we're pulling from. And then the next is going to be the column name that we're pulling from. And the first one is MCB180A. Then we're going to do a square bracket and do the same thing. NH, MCB180A. And what we want to do for this is anything larger than 77776, we want code as NA. And this is because the values for don't know are 5 9s, and the value for refused are 5 7s. So that means anything above this refused value, which is don't know, will be converted to NA. So it kind of takes care of both at the same time. And so we have to do this for 7 different variables. And so to make this go a little quicker, we can just take this, copy it, paste it, and we'll do that for each of the variables. And we can just change what the column name is that we're using, so it will go through for each of those. So we can go ahead and do B, C, D, E, F, and G is the last one. We can go ahead and run these. And it looks like they all went through okay. The primary variables that I chose to work with were MCD180A, which is age when told you had arthritis, and MCD180B, which is the age you had heart failure. So to start out here, we're going to create 2 new categorical variables out of the continuous variables above. So let's just make a comment to remind us what we're doing. For MCD180A and MCD180B. Okay. So first, we're going to create a new column name. We're going to start off with the same data set, and we're going to name our new column MCD180A underscore categorical variable. And we're going to define this as cut, the data set we're going to cut, NH MCD180A, comma, breaks, which is just saying where you're going to break up the data set. And now we're going to list off where, which is going to be at 18, 34, 54, and then 100 as our top end. Note that this data set only goes up 85, but we're just going to use 100 as a nice easy number. And next, we want to tell it that we're going to include the highest value. And we do this by pressing or typing include dot highest equals true. So we're going to want to continue this to now label these groups that we created. And to do this, we'll do a comma and enter down to the next line, labels equals. And now we want our first one to be 18 to 34, 35 to 54. Oops. And then lastly is going to be 55 plus, so 55 to 100. Now it's important that the number of labels you have here is equivalent to the number of categories you make above, or else it won't run. Okay, and so this looks like it went through without any errors. So next we're going to want to make the same categories, but for the MCD180B variable. And to do this, we can just copy the code we had previously, paste it down here, and change this variable name MCD180B underscore cat, and then change where we're pulling from in that column. And then we can just go ahead and run that, and it'll do the same thing. And it looks like it went through without any errors down here. So what we're going to want to do is run, let me get this a little more space down here, run frequency tables. We'll run frequency tables on the categorical variables that we just created above. And I'll make a note. Okay, and to do this, all we have to do is table and then list our dataset name or our column name. So I'm just going to go ahead and copy this name here, insert it into the table below, and run the frequency table. So now you can see our labels have been applied and the frequency table is created. So there's 211 people between 18 and 34, 670 people between 35 and 54, and then 732 people who are above 55 years old. And so we can do the same thing below the other variable that we created, and let's just change this to a B and run this. And so now we can see the same labels assigned, but now this is for the variable MCD180B. So between 18 and 34 years old, there's 15. 35 and 54 years old, there's 49, and for 55 plus, there's 131. Next, we're going to run summary statistics on the continuous variables for both of these before we turn them into categorical variables. And to do this, we're just going, first I'm going to make the comment, so calculate summary statistics for above continuous variable. Okay, and to do this, we're going to run a summary command. And we're going to define the data set and the column name. So it's MCD180A. We can go ahead and run this. And down here, we're going to see that we have minimum, first quintile, median, mean, third quintile, and max, and our number of NAs. And we can just go ahead and copy this down, replace this with a B to run our second summary statistics table down here. All right. So next, we're going to create a box plot using MCD180A, which is age when told you first had arthritis, and INDFMPIR, which is the income to family poverty ratio. So let's start with creating a simple box plot. Actually, we're going to start off with converting our categorical variable up here into a factor variable, so we'll be able to use it in the box plot formula. So we're going to convert MCD180A underscore cat into a factor variable. So to do this, we are going to first list the data set and MCD180A, and we're going to come up with a new name for this. So I'm just going to add an underscore F at the end of this so we know which one to pull. The formula is going to be as.factor. And then our data set and the column name, which is that categorical variable, MCD180 cat. And we're going to go ahead and run this. So now that we have our categorical variable converted into a factor, we can go ahead and create a simple box plot. So the formula for this is going to be BG plot, the data set name, AES for aesthetic, and then we're going to do our X variable, which is our MCD180A cat, the factor variable. Then we're going to designate our Y equals INDMPIR. And at the end of this, we're going to do a plus sign to indicate that we're going to keep working on the bottom line. So here we are going to do BEOM underscore box plot and close the brackets there. Okay, so we're getting an error. What's that? Oh, I spelled this wrong. There we go. Okay, so we can run that and we can see a box plot created here under the plot on the right. Something to note is that the NAs are showing up in here. And so I'll show you now how to remove those NAs from the box plot. Okay, and to do this, first we're just going to copy down our original code since we know it works. Paste that in here. So we want to say NH is not null. Is not NA. So here we are just saying we want to only include values where MCD180 categorical is not null. Oops, I put it in the wrong section. Move this. There we go. Okay, so now we're going to go ahead and run this. So now we can see that the NAs were removed. So next what we're going to do is we're going to add a title and footnote. To do this, we're going to copy over our original code now that we know it works. And after this, we are going to add a labs command. So we can do, first we're going to do our axes. So we will do X equals age category when greatest. We're going to do Y equals as family income to poverty ratio. We're going to do a comment, just move it on to the next line so it's a little bit easier. And we are going to do title equals family income to poverty ratio by, and I will just copy this down for ease. Okay, we'll do a comma and then add a function. Equals. This is where we'll put 2017 to 2018 national survey. Let's go ahead and run this. And so now we can see that there is a title up here, axes titles, as well as this subcaption down here. So one thing is we want to center the title and maybe center this as well. So let's center the title. So again, we can just copy down our code that we know works. And to do this, we're going to add a theme. So we're going to do a plus sign to continue the code on the next line. We're going to do theme plot title equals element underscore text each just equals 0.5. And then we're going to do the same thing for the caption. So to do this, we're going to do comma plot dot caption there equals element underscore text. And then we're going to do each just equals 0.5. Okay, and now we can go ahead and run this and see what it looks like now. Yep, so that's perfect. So we have this centered and we have this down here centered, which looks much better. So to give more information on our box plot, we can add mean. So to do this, the first thing that we're going to have to do is create the formula for calculating the mean. So we're going to create a function. So create mean function. And to do this, we will name the function underscore mean and define the function as function, do a curly bracket, go to the next line, return data.frame y equals mean x. And then we will do label equals round to round that number, mean x comma and a dot rm equals true. And then we are going to do a comma digits equals. Okay, I'm just going to bring that curly bracket and run that code. So we can see over here in our environment that that function was created. So now we can add the function as a visual dot and as a label on our graph. So add mean as dot and label on boxplot. So first we're just going to copy down this code that we know works. Then add a plus sign to the end of it since we're adding more information on, and then we are going to do stat underscore summary fun equals mean GEOM equals, we're going to do point for this. And we want the color of this point to be black to appear professional. And then we want the shape to be 19, which is just a point or a circle. And we're going to want the size for this to be 3. So this is going to give us the point on our graph right here, but we're also going to want to show the number of the mean. So to do this, we're going to do the same stat summary fun.data equals, and this is where we're going to bring in our function that we created, fun underscore mean, comma, GEOM equals text. We're going to want the color of this text to be black, and we're going to want the adjustment to be slightly above the dot. So to do this, we're going to do v just equals minus 0.7. Let's go ahead and run this and see what we get. Okay, so we can see now we have that dot showing us the mean visually, as well as this text above showing us the exact number that the mean is for clarity. Another thing that we can do here to make it more professional is to remove these grid lines in the back. Okay, and so to remove these grid lines, I'm just going to copy our original code again, bring it down here, and add another line of code. And so to do this, we're just going to want another theme function. So theme panel.border equals element underscore blank. And then we're also, so this removes the border. Looks like I spelled that wrong. This removes the border, and then the next one is going to remove the major grid line. So to do that, we're going to do panel. Oops. Here we're going to do panel grid major equals element underscore blank. And lastly, we're going to want to remove the minor grid lines as well. So we're going to do a panel grid minor equals element underscore blank. Now we can go ahead and run this, and we have our final publication worthy table. So to export this table, you can just go here and save as image or copy to a clipboard to copy and paste, or save it as a PDF. So if we save it as an image, we just get it like this, and we can put this in whatever journal that we're working on. So that is the end of my tutorial. Thank you very much.